Good morning, students. Now we are going to begin direction cosines and directions ratios, a very important topics of our class 12th higher mathematics. So our today's topic is direction cosines and direction ratio. What is the direction cosines and what is the direction ratio? Very easy method we can easily express it, or we can easily learn it by three-dimensional Cartesian plane. Here x-axis, y-axis and z-axis, and this is our origin. X, Y, and Z axes are in three-dimensional Cartesian plane are three mutually perpendicular axes. Here we take OP is any vector whose magnitude is R. In this way, OP is any vector whose magnitude is R makes a certain angle with x-axis, with y-axis, and with z-axis. If I say OP vector makes an angle alpha with x-axis, OP vector makes an angle beta with y-axis, and OP vector make an angle gamma with z-axis. Here is very important thing that these angles are measured positively, or we say angle measured anti-clockwise. So OP vector is any vector which we have choose, and magnitude of its R. R is the magnitude of OP vector, and angle make OP vector makes alpha, beta, and gamma angle with mutually perpendicular axis x, y, and z. So alpha, beta, and gamma. Alpha, beta, and gamma said to be the direction angle. Direction angle of OP vector. And when we take cos or we take cosines of this angle, we get direction cosines of vector OP. We see cos alpha, cos beta, and cos gamma. So it is very clear that cos alpha and cos beta and cos gamma are the direction cosines of vector OP which we have used. OP vector direction cosines will be cos alpha, cos beta, and cos gamma. Usually we use the notation for this direction cosines will be L, M, and N. So we say A, M, and N are the direction cosine of vector OP. N are the direction cosines of vector OP, whose magnitude is R. L, M, and N. Here is very important that all these angles measured positively or anti-clockwise. But in other situation, when angle measured negatively or we say in clockwise direction, then L will be equal to cos of pi minus alpha, N will be equal to cos of pi minus beta, and N is equal to cos of pi minus gamma. By use of mathematical principle, cos of pi minus alpha will be equal to minus cos of alpha. Cos of pi minus beta will be equal to minus cos of beta. And cos of pi minus gamma will be equal to minus cos of gamma. Or in other words, we can say the direction cosines of OP vector are unique, either LMN or minus L, minus M, minus N. L, M, N are minus L, minus M, and minus N. This is the direction cosines of any vector. Now we come to the direction ratios. What is the direction ratios? Again, we come to its second part of this video, direction ratio. What is the direction ratio? Direction ratio is nothing but certain numbers which is proportionally relation satisfied with L, M and N. According to definition, L, M and N are the direction cosines of any vector OP, then L upon A, M upon B and N upon C. Here A, B and C satisfy the proportionality relation with L, M and N. Then we see that A, B and C are the direction ratio of this vector. Are the direction ratio of the vector OP. Here is a very important fact that we have L, M and N are the unique values, except the unique values, but A, B, C have the different type of values. We see that by example we can easily understand it that L upon 1, M upon 2 and N upon 3. For example, 1, 2, 3 is the direction ratio of any vector. Then 1, 2, 3 satisfied the proportional relation with L, M and N. But L upon minus M upon minus 2, N upon minus 3 is also satisfied this relation. Or we say L upon 4, M upon 8, N upon 12 is also satisfied this relation. Or we say L upon 5, M upon 10 and N upon 15 are also satisfied this proportionality relation. Then we say we are to say in condition that 5, 10 and 15 are the direction ratio of this vector. Or we say 4, 8 and 12 is also direction ratio of this vector, and minus 1, minus 2 and minus 3 is also direction ratio of this vector. In this way we see that A, B and C are not unique. They can have many types of values A, B and C. This is the major difference between direction ratio, direction cosines and direction ratios. Now we come to its properties. Properties of direction ratios. What is the relation between L, M and N, or what is the relation between direction cosines? First of all, properties of direction cosines. First property is that L square plus M square plus N square is equal to 1. Now we prove it again. X, Y and Z axes are three mutually perpendicular axes. OP is any vector whose magnitude is R, and X, Y, Z are the coordinates of this point P. X, Y and Z. When we see that X, Y and Z are the coordinates of this point P, then we can easily see that OQ, distance OQ will be X, and angle alpha. OP vector makes angle alpha with X axis positively. So We can easily find out the value of cos alpha. What is cos alpha? Cos alpha is equal to base upon hypotenuse. Here OPQ is in right triangle, then OQ is its base and OP is its hypotenuse. Then cos alpha will be equal to x upon magnitude of OP vector. Or we say simply x upon r. So we get cos alpha is equal to x upon r. Again, beta is what is the what beta? Beta is the angle made by OP vector with y axis in positive direction. Cos beta is equal to again y upon r and cos gamma is equal to z upon r. R is the magnitude of OP vector. Since x, y, z is the x, y, z is the point P, then what is the in form of I, J, K? Are we said what is I, what is J, and what is K? I is the unit vector along x-axis, J is the unit vector along y-axis, and K is the unit vector along z-axis. Then we can easily express it in this form of IJK, OP vector. We can easily write it OP vector is equal to xi plus yj plus zk, or we have to see OP vector is equal to xi cap plus yj cap plus zk cap. So what is the OP vector? Modulus of OP vector, or we say what is the magnitude of OP vector? So OP vector is equal to x square root of x square plus y square plus z square. We find it OP vector magnitude of OP vector is equal to root of x square plus y square plus z square. So in this relation, when in the left hand side we have to substitute the value of L, M and N. This is L, this is M and this is N. When we substitute the value of L, M, N in the left hand side of this relation, we get cos square alpha plus cos square beta plus cos square gamma. Again, cos square alpha is nothing but x upon r whole square, or x upon x square upon root of x square plus y square plus z square plus y square upon root of x square plus y square plus z square into z square upon root of x square plus y square plus z square and again whole square. So we get x square upon x square plus y square plus z square plus y square upon x square plus y square plus z square and z square upon x square plus y square plus z square. Finally we get x square plus y square plus z square. X square plus y square plus z square, because denominator is same, then LCM will be x square plus y square plus z square and numerator will be x square plus y square plus z square. Cancel out, is equal to 1, which is our right hand side. So we see that L square plus M square plus N square is equal to 1 by the 3-dimensional Cartesian plane, and x, y, z is its coordinate of point P. Then we can easily express it in the form of IJK. OP vector is equal to xi plus yj plus zk. Again, its second property is now we come to the second property. Second property, what is the direction cosines of x-axis, what is the direction cosines of y-axis, and what is the direction cosines of z-axis. Direction cosines of x-axis. Since we know that x-axis makes an angle 0 degree with x-axis, then L will be equal to cos of alpha is equal to cos of 0 degree. Again, since we know that x-axis, y-axis and z-axis are the mutually perpendicular axis, then we can easily say that L is equal to cos of beta is equal to cos of pi by 2 and N is equal to cos of gamma in cos of pi by 2. So cos 0 is equal to 1, cos pi by 2 is equal to 0 and cos pi by 2 is equal to 0. So we say that direction cosines of x-axis will be equal to 1, 0, 0. Similarly, we can find direction cosines of y-axis will be equal to 0, 1, 0 and direction cosines of z-axis is equal to 0, 0, 1. This is its second property. So in this video, we have learned thoroughly what is the direction cosines, what is the direction ratio, what is its definition, and properties L square plus AB square plus L square is equal to 1, and its properties, what is the direction cosines of x-axis, y-axis and z-axis. Thank you very much. Jai Hind, Jai Bharat. Next time.